Hi, welcome to episode 41, wow, of the ChessTDD series. At this point, I believe, let's see, I actually just recorded or did the coding for like three of these in a row, so I'm trying to remember what exactly I was doing last time. I think this is the episode. Oh, yeah, so top on the priority list was to go back and I remember, although it was a while ago now, I remember thinking that this is non-capture allowed method was a bit fishy. So I had put a kind of a pin in it and said like, well, let's go back and, hit this with tests at the unit level, sort of granular unit tests, and let's TDD this thing without like acceptance tests and attack it that way. And that seems like a pretty good plan. The reason I like to do that, like when I'm going between those levels of abstraction for me, is for me, when I'm writing acceptance tests, it's to either check something that I've done, or if I'm doing acceptance test driven development, um, it's sort of to conceptualize things in terms of requirements. So, like maybe I'd have a chessboard that was all set and there was like a new feature that was wanted. And so I'd start out with a failing test for that. But so at this point, there's an algorithm in here that I have a little more of a desire to attack in fine-grained fashion. Like I have a good sense of what it actually means for is non-capture allowed for pawns. So the lesson I'd maybe take away from this is that there's a lot of judgment to be had here, but test-driven development versus acceptance test-driven development is going to tend to be good for when you want to do a lot of fast iteration that you understand pretty well. So in this case, I understand the algorithm, and to go through all the hoops, I guess, of setting up those visual boards and everything for like every conceivable scenario pawn kind of seems like overkill to me. So that's why I'm kind of down here at the unit level. And so at this time, I was sorry, that's my cat making noise. I think he's hungry. I was sort of like shaking off the rust here and trying to remember what it was exactly that I'd been doing, and so it took a minute. But I started out having learned the lesson from last time, and wanting to abstract this method out right away, because I know that I'm going to be making this can make non-capture. Like I'm going to do a repeated series of these of this to tease out the algorithm. So instead of waiting for a few different tests where I saw the duplication, I just refactored it while it was green to do it right away. That's something that may be worth noting there too. You can at times certainly wait until you have instances of duplication. Some people might say it's like speculative to factor out a method when you don't know for sure, I guess, or you haven't, actually felt the pain of the duplication. I've sort of come over the course of time to think that, like, I don't mind extracting a method. I don't know that it's speculative because, I'm about to use it in the next test. And frankly, even if it is a speculative extraction, it still makes the class more readable. So, I don't know if you'll hear differently. I think it's perfectly acceptable to go and factor out this method, put parameters into it, and, then use it in subsequent tests. It's just less typing, keeps the test methods more readable. So sort of back to the problem at hand here. I was trying to like refresh my memory as to what all was going on here with the other methods in this class. This is in the old style of just having the one-to-one unit test class to class under test. So I'm feeling the awkwardness of this just a little bit. So what I'm doing right here, I didn't have any strong hypotheses if memory serves, as to like what would or wouldn't work. I was just, this thing wasn't covered, so I wanted to cover it with some tests and get a feel for what I had done last time. Like if you've forgotten, this is another lesson to be learned here. If I may have talked about this before, but I'm almost writing like characterization tests of my own code, and characterization tests are, in essence, where you take a piece of code and you just like kind of figure out what it's doing. You write tests with the idea that you'll always get true. And you do that with legacy code. You call it characterization because you're not really making any assertions as to how it should behave. You're just figuring out how it does behave. You're learning about the code while writing tests. And the reason you do that in legacy code bases is that if you're going to like refactor and clean it up and change it, you want to characterize its current behavior so you have a warning system for if you're changing things. Because with legacy systems, even if the behavior is sort of ostensibly wrong, like if you had some method called add that took two integers and when you handed it 2 and 2, it returned 5. In a legacy code base, is that like clearly that seems wrong, but maybe clients of that code figured out that wart a long time ago and just subtract 1 whenever they call add, and so you'd make that correction, so to speak, and they'd come back and yell at you that you broke their code. So with legacy code, you want to characterize and then have an understanding of whether you're changing it or not so much what's right or wrong. Now, in this case, that's sort of I was saying it was like writing characterization tests, what I was doing. So my aim wasn't to say that this is like some crufty code in production that I just have to like understand what it's doing so I can change it. Here it was kind of like I'm writing tests and I'm not sure whether they're going to pass or fail. And I'm writing those tests to kind of regain my understanding of what the code is doing. And kind of simultaneously, I was actually writing tests that all should pass. So I was kind of writing test after test that I knew should be true to see if any of them would fail. And then I finally got to one that did, and started to figure out, oh, okay, so there's this concept of whether you've moved or not. So I'm not doing a good job with that in is non-capture allowed. And in fact, I'm not doing a good job with a few different things here, but so I'm trying to use these abstractions I have to see if I can get to green, and I'm not having a lot of luck. And it's because I don't remember if I fixed it in this episode or one of the future ones, but these is over 1 and is up 1. They're clear from a readability perspective, but I don't know if as written they're like super helpful. So that's something you think about too. When you're refactoring for readability, that might not always be exactly the same thing as refactoring to pull out something common. So I kind of there's almost like a sunk cost fallacy thing going on. It's like, well, I've got these readable abstractions, so I should use them. And maybe I'm not like entirely clear on whether that's the right abstraction here or not. And I remember that this class got a little goofier before it got better. I spent a lot of time in this class over the next 3 episodes or so. So I'm struggling with figuring out how to say, basically like, okay, so what are the non-capture moves allowed for a pawn? It's in essence like the only one allowed is to go 1 forward, unless the pawn hasn't moved, and then you can go 2 forward. So I'm trying to figure out the best way to capture that in here. And I think I did it right. So like, all right, if the pawn is moved, or if the pawn is not moved, no, I'm sorry. If the pawn has moved, like this reads correctly. So is up 1. That's that reads right off the top. So like, I wonder what's going on. Why is it getting in here and failing in this acceptance test? So I wised up a little bit and realized that I was getting a lot of false hits, and I should probably to figure out, to get to the point where it's actually the acceptance test in question running here, I should put it inside the conditional. Okay, so this seems right. If the origin is 1-3 and the destination is 1-4 and I've moved, what's the problem here? Is up 1? Yeah, that looks right. And this is like sort of, as you watch me struggle a little here, this is kind of why sometimes I'll go into the unit mode to really tease things out, because when you drive from acceptance tests, especially when there's a lot of code that exists, it's good because you're putting into place like real world scenarios, but there's a lot of stuff going on. Whereas when you're at the unit level, you can be a lot more focused. And so what seems to be the problem here is the way it's kind of all getting tied up with this like move legality and everything. So it doesn't appear necessarily to be a problem with like is non-capture allowed. I don't know that's what's creating my headache. Maybe it is. I might be confusing a problem I had later. My apologies. And I don't remember exactly what was going wrong here. I look sort of confident now, though. Got rid of the debugging point. I think I have an understanding. So not only do I have to check to see if it's if we've moved that it's over one, I also have to check to make sure it's not like a diagonal move as well in that scenario. So that was a relatively simple logic error that I was making. So onwards and upwards. So for the next test here, I see that this wasn't something I'd really covered yet. I want to make sure that like when you ask whether a non-capture move is allowed, and if you were to give this thing something like 3 moves forward, see, that's a problem. I had a suspicion that that would not work properly. Like, we obviously shouldn't be allowing moves that the pawn can't make anyway. One way, and I didn't do it this way, but a way I might have thought of doing this was kind of to see if, I could have just checked get moves from for origin coordinate and then narrowed it down. But I went the route of, I guess there's a little bit maybe of duplication. It might be something to fix later where I'm saying like, okay, well, let's figure out what, capture and non-capture look like sort of explicitly, which I guess also, you might make a philosophical argument either way. One would think that like the whole set of moves, and get moves from consists of the set of capture moves and non-capture moves. But I don't know off the top, and I wasn't really thinking through whether that would actually be, a complete set. It sure seems like it would be, since capture and non-capture are mutually exclusive. So anyway, that might be a refactoring target for later, is not a higher priority thing. And an interesting lesson to take away from that too is that like, so that's a little bit of very subtle duplication perhaps going on in my code. And the duplication can be subtle. When you hear about don't repeat yourself, usually you think of copying and pasting code. I talk a lot about that in this series, and you'll hear people talk about it as well. But knowledge duplication can occur even when you're not actually copying and pasting code. It can occur if you're sort of solving the same problem twice, which is what I'm doing in a way here, potentially. Even if you completely code the 2 solutions in different ways, and you're in very good faith not doing any copy and paste, you can still have that knowledge duplication. The idea of avoiding duplication, don't repeat yourself, like the real core idea there is that you only want one source of any piece of knowledge in a software system. And that's not just in the code, it's in the database or, the file store, whatever it is. And the reason for that is relatively straightforward. It's that if you're sort of defining a solution or you're defining a piece of knowledge twice, then if that changes, you have 2 places to change it. That's problem number 1. And problem number 2 is the 2 sources of knowledge, sources of truth can become out of sync and create subtle bugs. So that's sort of a long-winded explanation of why I might be making a mistake that I only see here in pairing with myself in this second pass through. But to be determined, I'm not even entirely sure that's what's going on. So we'll see. Might be a good way to refactor this later. I wouldn't worry about it too much now because, spoiler alert, this class undergoes a significant amount of change as I start to, in the next couple episodes, look at what it's like for the black pawns to move in the other direction. So I'm going through here and I'm trying to keep the naming a little bit better. I'm trying to keep this method readable. And it seems to be for the time. So I'm saying, in non-capture, is a non-capture move allowed for a pawn? Like, well, okay, so if it's moved, then we just want to see, is the move we're being passed a move that's 1 forward? because that's the only thing. Otherwise, right now I have this kind of confusing thing that gets refactored, I believe. I don't know if I do it right away. Like, so if it's moved, then we have a pretty straightforward thing. Otherwise, is it up one and not over one? And I think it's at this point that I start to really kind of think, like, is this over one and up one like the abstraction I really need here? And so with all my tests green and, in the sort of fearless refactoring mantra, I'm going to make some changes here. So I get this idea in my head to say, like, okay, maybe instead of doing like, baking a 1 and a 2 into the name of a method, like maybe we can actually, use a variable. There's a thought. So I'm going to have this vertical spaces, and then I can say, well, if it's moved, check to see, is this a vertical move of 1? Otherwise, if it hasn't moved, check to see if it's a vertical move of 1 or if it's a vertical move of 2. So something worth noting in general, it's all well and good to factor out abstractions to have them be readable, but be open to and willing to change those up. It might be that they outlive their usefulness, that you need to reconsider them or chain them in different ways. And that's kind of what's going on here. It was obviously useful to me a few episodes ago, but now it's getting a little confusing, so it's time to kind of reconsider this. And it's getting a little late into the episode. I remember I had grand designs that I'd just kind of tease out this one card real quick and then move on to the black pawn, but it wasn't meant to be because I was making mistakes here, such as in this one, inverting X and Y. It took me a minute to figure that out. It always seems I'm trying now to do these episodes in batches of like 3 or 4 at a time. So I'm actually like sitting down and coding for, like an hour plus instead of like 20 minutes. And once I get into the groove, I start to not make as many stupid mistakes. So, hey, there's like a, meta lesson out there for anybody who's watching. Show this to your managers. If they come and interrupt you every 20 minutes, you're a lot less productive. The proof is in the pudding right here. You can have them watch this as a case study. I make a lot of dumb mistakes when I'm interrupting myself every 20 minutes, especially if I can't come back for a while, like a week or whatever. But I'm getting there. And so now I'm looking at an abstraction that's starting to look a lot cleaner here. So I have this unreachable code, but it's green, so I know I can delete it. And that looks better. So what started out, as a helpful abstraction, I'm starting to reconsider these, and I'm winding up with this method that before looked a little iffy. There was like an inverted conditional and then like parentheses and, De Morgan's laws and all that. Now I've got something that's nice and readable that you're getting back again to something that like a chess player might understand. So at this point, I got it into my head. It was kind of close to the end of the episode, and I was feeling good about like driving out with TDD, that method about like non-capture moves being allowed. But I started to think like I'm doing all this like is over one, is up one, and then I was thinking like, don't I have this like concept in the base class? Like, is this a vertical move? Is it a horizontal? Is it a diagonal? So I started to think like, why am I redoing that? So what I could maybe do here is see if I can, use this get radial diagonal 1 away from this origin coordinate, and then just see if the destination was, 1 away diagonally. Now I know that's going to create problems for me when I start differentiating between the black pawns and the white pawns. But for now, all I care about is keeping my test green and, maybe reducing my code footprint here, because I think these is over one, is up one, like I got rid of that from is non-capture allowed, so maybe I can kill that code in is captured allowed. I stay green. Now I can delete these 2 methods, and that's a win. So the class is more compact. I have fewer private methods helping me out, which is something I always kind of try to strive for. It's not that there's anything wrong with private methods, but I like to stay away from iceberg classes because those get hard to test. So there we go. Now we're back to having a lot of public-facing methods. It's more readable. I'm kind of liking the way this shaped up. So seemed like a good stopping point. I am going to call it on well, oh yeah, I'm defining one more auxiliary method here. So I lied. There's going to be maybe a second. Oh no, this was in a whole other class, so it's totally fine. Who cares? No, I'm just kidding. I'm just going to define this overload. I guess everywhere else I was using this concept of matches. I was doing it with the X and Y coordinate, but here I kind of want an overload with the actual board coordinate because, that's just what I want there, and it seems like a reasonable enough thing to add. So I'll just make this call into the existing logic and avoid that subtle piece of duplication. Everything stays green, life is good, and this is pretty readable, so it's a good place to wrap up. I'll move that card over, and then take a look at what's here. This is going to be the next thing, like, go back through, and yikes, I was at this point kind of terrified of the logic, converting all this logic that's like very clearly specifically designed for only white pawns, and like, okay, so how do we go and like fix this for the black pawn? So stay tuned for that. In episode 42, you will see me take a swing at it. So I will see you next time. Thanks for listening.